Alright guys, so this video is on strong versus weak electrolytes. It's really just what dissolves and what doesn't dissolve. So what are electrolytes? Electrolytes are ionic substances that when dissolved in water produce a conductive solution. So remember, like if you take salt, table salt, and ACl, and you put it in water, it turns into sodium ions and chloride ions. And so those ions, when they're in water, allow electrons to pass through the water more easily. All right, and electricity is just electrons. Sodium ions and chloride ions would be electrolytes. All right, so strong electrolytes are ionic compounds that completely dissolve in solution. All right, so they make a whole lot of ions. So it'd be like sodium chloride. All right, so soluble salts according to solubility rules, which is what we're going to cover soon, and then strong acids and bases also dissociate completely. Weak electrolytes are ionic compounds that only marginally dissolve or partially dissolve in solution. So they don't make many electrolytes because they don't all completely turn into ions. So if we look at silver chloride, which is insoluble according to the solubility rules, it doesn't all dissolve. All right. Only some of it does. So if you have 10 of those, you might get 0.001 of these. All right, so it's very, very insoluble. Only a little bit of it dissolves. So we don't get near as many ions in solution, which makes it less conductive, which makes it a weak electrolyte. It dissolves a little bit, but not much. So non-electrolyte are compounds that dissolve in water, but they don't produce ions at all. So if we look at sugar like glucose, right? We know sugar dissolves in water. We put it in tea and Kool-Aid and all sorts of stuff, and it dissolves, right? But it doesn't dissolve into any ions because it's a molecule. It's not ionic. There are no ions that make it up. So it dissolves because of an attraction to the water molecules. It doesn't fall apart like these here and these right here do. All right? So anything that's an organic compound or molecular compound like that, okay? Or if you have something like this, that's ethanol, okay, it's going to dissolve in water. Alcohols dissolve in water, but they don't make any ions. So that means they're non-electrolytes because they don't allow a conductive solution to be formed. All right. Okay, so what happens when we add salt to water? So this is a crystal lattice structure of sodium chloride. All right, the purple ones are the sodiums, and then the green ones are the chloride ions. If you'll notice, every single chloride, right? If we look at this one, it's bonded to 1, 2, 3, 4 sodiums that we can see. There's also one right behind it, and there would be one in front of it. So each one is bonded to 6. And the sodium ions are the same way, right? Each sodium has 1, 2, 3, 4 chlorides. There's one behind it, and then there's one in front of it. So if you go back and you look at empirical formulas, that's why these generally are already an empirical formula, because they form these big, huge structures. All right, you wouldn't be able to see a grain of salt if it was just 2 atoms stuck together. So it's many, many, many pieces stuck together. All right, and what happens, water, because it's polar, right? Water is a polar molecule, so it has a partially negative end and partially positive ends. The partially negative end is attracted to the positive ions of the sodium, and the partially positive ends are attracted to the negative ions of the chloride. And when you put the salt into the water, it pulls it apart. All right, so the water basically just rips apart the sodium chloride lattice structure one at a time. And what you end up getting is you get a water molecule, and it has 2 pairs of electrons that are then attracted to a sodium ion, and it gets surrounded. So that sodium ion gets surrounded by the water molecules. Oops, I used a different blue. It's okay. And so remember that the negative end of the water molecule is going to be attracted to the positive ion. All right, and the oxygen is the negative end because it's more electronegative, right? So it's pulling the electrons up. We'll cover that in much more detail later, but you do need to know it. All right, so chloride then would have the opposite. The hydrogens would be facing the chloride. They're dissolved in the solution. And eventually you get to a point where you can't dissolve any more salt because the water molecules are not available to do that anymore. All right, the solubility rules. So salts containing alkali metals are always soluble. So group 1, right, which is right here. There we go. Okay, and then salts containing nitrates, perchlorates, chlorates, acetates, and ammonium are always soluble. Salts containing the halogens, so this group right here, right, it's really chloride, bromide, and iodine. They are soluble unless they're with silver, lead, or mercury. And then sulfates are soluble unless they're with calcium, strontium, barium, silver, or lead. These rules vary depending on which textbook you look at. But on the AP test, they want you to know that sodium and potassium ions are always soluble. So just know this group 1 is always soluble unless they otherwise state it in the problem. And you have to know that nitrates are always soluble, ammonium is always soluble. Everything else they're supposed to give you on the test now. All right, so insoluble salts, hydroxides, and sulfides are insoluble unless with calcium, strontium, or barium. So you just need to make sure that you know those soluble ones. All right, so for each of the following salts, determine if they are soluble and show what will happen in solution when they are added to water with a reaction. So I don't want you to add it to water with a reaction specifically. I just want you to write the dissociation because this is important that you can do this later. So for the first one, sodium chloride, it dissolves into sodium ions and chloride ions, just like that. And then silver chloride is insoluble, right? Because it's a halogen and it has silver in it. So we use these arrows because it does dissolve, it just doesn't dissolve great. All right, and then we have potassium sulfide. And potassium ions are always soluble because it's an alkali metal. Even though it says sulfides are insoluble, it's with one of these, so it's going to be soluble. So we have potassium plus, and then we have 2 sulfides. And then calcium sulfate is considered insoluble. Okay, and then the last one is ammonium cyanide, and ammoniums are always soluble too. So we use those arrows. So if it's soluble, you use the single arrow, and if it's insoluble, you use the equilibrium arrows. All right, so in case you're wondering about these charges, remember all of these are +1. Here's +2. Then we've got aluminum is +3. And then the nitrogen compound, -3, or nitrogen atoms group, -2 and -1. So if calcium is +2, then sulfate has to be -2. You really should have them memorized. Knowing that, and going back to what was on the first slide, this would be a strong electrolyte, this would be a weak electrolyte, this would be a strong electrolyte, a weak electrolyte, and a strong electrolyte. So if it's completely soluble, then it's a strong electrolyte. If it's considered insoluble, so it's only marginally soluble, then it's a weak. All right, strong acids and strong bases. So the strong acids are hydrochloric, hydrobromic, hydroiodic, chloric, perchloric, nitric, and sulfuric. You need to have those memorized. And the strong bases are really, really easy to remember. That's why I put them on here, because they're the hydroxides that go with these. All right, so lithium, sodium, potassium, rubidium, cesium, calcium, strontium, barium, hydroxides, right? And it makes the shape of a B. Nitric acid is strong, although some books don't list it as strong. It's got a very high dissociation. All right, so we get an H plus and a nitrate. And then nitrous acid is not strong. All right, and then we have hypochlorous acid. It's not strong. Oops, that one is strong. It's not strong either. So barium hydroxide is strong. and it dissociates into barium ions and 2 hydroxide ions, and then we have potassium hydroxide, which dissociates into K and OH because it is strong as well. All right. So, summary: soluble salts, strong electrolytes, and strong bases are strong electrolytes, and they dissolve 100% in solution, so we always use that arrow. Insoluble salts, weak acids, weak bases, or weak electrolytes. They dissolve very little, and the amount that they dissolve is specific to their identity. So if we're looking at HF, that's a weak acid. It does not dissociate completely, and it doesn't dissociate the same amount that this weak acid dissociates. It's very specific to that acid. And we'll discuss that when we talk about acids and bases further, but you always use these arrows with weak electrolytes. And the only way to know which ones are strong and which ones are weak is to have it memorized.